Okay. So whenever you feel you have a question or if any point is not clear, please do interrupt me and ask your question. Okay? So actually, I will be sending in the chat right now. I will upload the PowerPoint that I'm using for Arduino by topic. It's like Arduino. I have two levels. So please do confirm when you receive the two files.
Okay, sure.
Okay, it will take like few seconds.
Yes, we received the two file, yeah, Mr. Wissam. Thank you.
Great. So I will not go through those two files. I prefer to go directly into the practical part by showing you how you can start Arduino with your student without any previous background. So mainly what you can see later on in the Arduino PowerPoint level 1 or level 2, you will see general knowledge about what is Arduino, what are the components of Arduino, where Arduino is used, how to, what are the components and the hardware that we are using in terms of input, output, etc., etc. So I believe that if you go through those files, you will have more and more data about this. That's why I'm asking you to download and to save those two files. They are very important and very useful for this. But once the introduction for Arduino is made for students based on the PowerPoint I've shared with you, you can go and start working on the platform in order to make things very easy and very practical for students. To make it clear, when we decide to start teaching Arduino, actually you have to work on the hardware. So the kits that you received, so students are asked to make a circuit, to plug a LED, to use the breadboard, the Arduino board, to make the upload, and to make the program. But since it's going to be your first, let's say, your first experimentation with students, so I believe that you have to start with. I have to share my screen. You have to share to start uh, with Tinkercad, and do believe that Tinkercad is a free platform that students can use just by signing in with their email. And this platform that you can see, I believe you can see my shared screen, right?
Yes, we can see it.
All right. So all you have to do in order to start working with Arduino virtually, because this step, it will simplify too much the task in terms of comprehension and assessment regarding the students. So from here, you click on the create button and you choose circuits. So students, before going through this manipulation, students should understand that we are you, and this is very important for you teachers to assimilate, that students should understand that Arduino as a microcontroller board is an experimental educational board that they can use to create STEAM and technology projects. And since this step is really critical for students to start directly with the hardware, so that's why the teaching process will start with Arduino in terms of Tinkercad as simulation, and then later on you will be moving to the hardware. So you can see on the right of the screen you have like tools. You have resistors, LED, push button, potentiometer, capacitor, etc., etc. So what you will be doing is you will be moving the Arduino board. Okay. After that, we can start explaining for students the main components of this Arduino board. So you will start by showing them that you have the USB port in order to connect the Arduino board to the computer for two reasons. The first one is to power up the Arduino board, and second is to transfer or to download the program from the computer to the Arduino board. And the second input is for the 9 volt 9 volt connector. If you want to, let's say, keep the power on the board without connecting the Arduino board to the computer. Here, keep in mind that on the Arduino board, I can't upload more than one program. So each time I upload a program, the previous one stored will be erased. So that's why you need the USB cable to upload the program. And once the program is uploaded, no need for this connection. If you have a 9 volt connection, so you can connect it, else you will keep the Arduino board connected to the computer. After that, you can see that you have pins up and pins down. And as a first step, you can see that pins are divided into categories. So here you have the digital pins from 0, 1, 2, 3, 4, 5 till 13. And you have the power pins down, which are the ground, the 5 volt, the 3.5 volt. The other are not very important. And you have analog pin that later on we will be exploring. So all what they have to understand, students, is that they have digital pins from 0 till 13. Then you have analog pins, which are the pins to be developed later, and the power pin in order to provide power. So now before starting any manipulation, look what I'll be doing. I'll click on the code part, and it's a surprise. I can see that I have a program already built using the Scratch coding. And from this program, you see that you have what we call the blocks: set built-in LED to high, wait 1 second, set built-in low, wait 1 second. To understand what does it mean, the set, the built-in LED, I will start my simulation by clicking on Start Simulation. And now you can see clearly that there is a button here which is blinking. You can see here the button is blinking. So here we can conclude that the program ready-made by Tinkercad is to make this small LED blinks. So as a first manipulation, I will stop it. I will hide the code. Then I will move the LED, which is the LED. And as you can see, you have the cathode and you have the anode. So based on those two legs, we can conclude that the cathode is the pin to be connected to ground, and the anode is the pin to be connected to one of those digital pins from 0 till 7, 8, 9, 10, 11, or 13. So if I
Um,
yes,
Mr. Wissam, just a question. The cathode always connected to the ground?
yes. Why?
Always.
Why
Um,
because in physics it's not like that.
no, because I'm teaching the student. I just want to be sure. Yani, when tell them the cathode is always going to the ground.
Yeah, yes.
Okay.
Okay. So here when I connect my LED to the cathode to the ground and 13 to the anode, and if I click on the start simulation, you can see that the LED is blinking, same as the built-in LED. What conclusion we can take from this? Simply, we can take a conclusion that the LED built-in LED, it's connected to LED 13. As simple. Okay? So, and how to make sure that what I'm saying is correct? I will stop my simulation. I will take this cable and I will connect it to digital pin 8. When I click on Start Simulation, look how this LED built-in LED is blinking, but this LED is not blinking. Why? Because I have to set my program to make the LED connected to 8 blinks. So I open the program and I take set pin. I choose 8 to high, wait 1 second, and set pin 8 to low and wait 1 second. Look how easy the programming is. I click on start programming, start simulation, and now you can see that the LED is blinking. Okay, but there is an exclamation mark. You have an error here. So it means that the current flow is high. We have to use a resistor in order to protect it. So from here, I can stop simulation and I will move to another step, which is adding an Arduino, a breadboard. So what is the use of the Arduino board? Simply, the Arduino board is the board where I can extend my circuit. I mean here, I have the first row, second row, the last two rows are connected horizontally. You see, the moment I place the mouse on one of the holes, all the holes are selected green, and this means that uh, uh, we have to extend our circuit in a clear way. But the holes inside are connected vertically. You can see how while moving the cursor, column is selected. So I start by deleting the LED. I will place a LED on the breadboard, and I will create a connection in order to connect more than one LED. So I go for the ground, and I select the first row. So here, all the the dots for the first row are connected to ground. So if I place two LEDs or even three LEDs, no problem. I can take one cable from here to the first LED, a second cable to the second LED, a third cable, and now all my LEDs are connected to the ground. Now it's time to connect the anode. So of course I will select one of the 13 pins. Let's say the first one to 7, second one to 4, and digital pin 1 to the third pin. So like that, my circuit is done. I will stop my simulation. So it's like 741. So I will delete all, set pin duplicate, 7, 4, and 1. Wait 1 second. Will duplicate all, and I will put them to low. Okay? If I click on start simulation, you can see that the 3 LEDs are blinking together. And here you can set the scenario as you want. If you want to make them blinks in order, in reverse way, so it's up to you to make this manipulation. Okay, now I will stop my simulation in order to introduce the resistor. And the resistor is very important in order to protect my circuit. But for the LED, the resistor value should be in ohm 220. This is a physics theory, okay, or a formula that you have to respect. So I'll take my first of all, let me move a little bit the LEDs. I think it should be here. So I will delete this and this, ground to ground, ground to ground. Okay, and for the first one, let me copy paste. Okay, so my second this one is sorry, is 4. I will move it here, and this one is 1. I will move it here. So you can see now that same circuit is done. I've integrated one resistor, and this resistor is connected to to the anode for each LED. Okay, so and it's set to 220 ohms. So if I click on start simulation, then the LEDs are blinking. Okay, and without the warning. All right. So this is how I protect my LEDs. I will stop my simulation. If I want to move from virtual to hardware, because since you have the hardware, it's very important to move uh, uh, to to upload the program from simulation to hardware. So all what you have to do is to click on the code. Look here, you have the blocks option. So I open and I choose blocks and text and see how the blocks are translated to C++ code. So all you have to do is to select the code, to copy, then to go to the program, where is my program Arduino? Just one second. So here I'm launching my program Arduino. Okay, I will select the previous code. I paste my code and I have to connect the Arduino board where I've built the circuit. And by clicking on this button, you will be uploading the C++ code to the real board Arduino, and the simulation will start playing. So I'd like to see to know from you if you have any till now, if you have any question, and if you want me to focus on something really specific. So please let me know in order to do this. Is it clear till now? You have
Uh,
any question?
um, yes, so far it's clear, Mr. Wissam.
It's okay. Okay. Uh, Now I will hide my code. I will hide my code, and if you follow the lessons proposed in the book, you can see that grade 7, 8, 9, by the end of the year, they are introduced to Arduino Tinkercad by simulation, and 10, 11, 12, the approach is on the what we call the hardware approach, where students will be asked to create by themselves the circuit. So can I ask you a question? Are you planning to give Arduino even for 7, 8, 9?
Yes, we started with our student, the Arduino, grade 7 to 11.
Okay, and
Yeah.
is simulation or directly by hardware?
No, first we started simulation. This week we started with the hardware, just some simple example.
Okay, and how many
Mm.
students you have in the class?
Not يعني many student. For example, in grade 7 we have like 13 student in the class.
Okay,
Yes.
so you,
So
you can manage giving them the hardware to manipulate.
to manipulate, yes.
Okay, great, great. So if you go through the lessons, you can see that there is some lessons where students will learn how to create calculation, how to create a variable, how to establish a condition if, or to control the looping system using the for loop. So this is why coding as a first step is very, very important for students to have a real background uh, regarding the coding, to link it with Arduino, and in parallel to the introduction of the variables, the looping, the if code, the conditions, you have what we call the uh, the serial monitor part. And here by serial monitor, I can see that uh, uh, it will be easy for students to what we call to visualize what's happening on the screen, because you can see that on the Arduino board, you don't have a screen to display information like humidity, temperature, distance, light, any kind of data that is connected to the screen, to the Arduino board and to the screen. So from here, we can assume that the serial monitor, it's very important to display information. And how we can do it? As simple. I will hide the code. Then I will take an example for the ultrasonic sensor. So here, if I move the ultrasonic sensor, you see that this ultrasonic sensor has 3 pins. But if you go through all the components, it's clear that you have an ultrasonic sensor with 4 pins. Almost are same logic of programming, okay? But we will see it with the code. Even if you take this one or this one, the logic of programming the code is very simple. So I will delete this one. I will insert let me check. Okay, this one. I will place it like here. And I will start connecting my cables. So the VCC cable, it's the cable to be connected to the 5 volt. This is clear. The trig and echo are the 2 pins to send data and to receive data. So from here, I can click on the trig and I connect it to pin number. I will delete this one. I will delete this one. I will keep one LED. Okay. All right. Okay, great. So the trig will be connected to pin number 6, and the echo is connected to number 5, pin 5. And the ground, as it's obvious and clear that it will be connected to the button ground. So after that, I'll be going to show you how I can make my coding. So I want my coding, sorry, excuse me. I want my coding to turn on the LED connected to pin number 1 if the distance detected is less than 15 centimeters. All right. So I'll open the code. Blocks. All right. I will delete all this. And I will show on the serial monitor. So from the output, print or print to serial monitor. Okay. What I have to print as input, uh, read ultrasonic sensor. You can see here the distance, but here I have a little bit problem. I have to make it bigger. So the trig is connected to, if you remember, to 6 and 5. So the trig is connected to pin number 6, and the echo is connected to number 5. So this block will display my data, my distance measured. So we'll go to the control and take one if blocks. I will take my condition. If the distance is less than 15, I can take this block. I'll put it here. So output set pin number 1 to high, and then set pin to low. I will hide my code. I will start my simulation. Look how the distance it's displayed on the serial monitor. I will click on my ultrasonic sensor to show the area of vision. So when I move, this is considered as the object detected. So when I take it far, it's like now 289 centimeters. When I make it closer, it's like 70 centimeters. And then I can make it all around. Okay. So you can see here the distance measured. And if it's less than 15, the lead is, sorry, I have to check here, is less than less than 40. It's not really clear. I will make it okay. Start simulation. So now it's like 141. Why it's setting? Ah, let me check. There is an error, I think. No? Let me check the code. 5, 6. If ultrasonic sensor is less, the trig is on the okay. The trig is on, I have to switch. It's wrong. Okay. So the trig is on 5, 6, I think 5, 6. Let me try. So start simulation. I know. The trig is on 6, and the echo, there is an error here. The echo is on 5, 6, 5. Trig 6, trig 6. A little bit weird. I don't know. I cannot see the error. 6, 5. Set pin 1 to high. Else set pin. Let me change it to 2. Maybe, I don't know. I have a feeling that 2 and 2. Let us start simulation. Okay. So now it's, I don't know why it's not working. Ground, backward. Can you see the error? VCC, ground. It's a little bit weird. Trig is 6 and 5. The condition is not working. If it's less than 40 centimeters, let me check. If it's less than 40 centimeters, okay. Now it's working, you see? So it's working. Less than 40, the LED is on. More than 40, the LED is off. So here you can see that all the combination of coding skills are here in order to make things happen. If I take here the block and text, you can see that all the code is written. All the code is written, and from here we can read it closely in order to make sure that students did understand the coding concept without making them memorize the code. So basically, I think that let me stop simulation. Sorry. Okay, stop simulation. So basically, the logic of coding or even of working with the course is really clear because it's related to practice and theory at the same time in the book. And I wonder if you are facing some difficult points or students are understanding or not. So I prefer to hear from you also your experience in order to check if we have to align it somehow. So can you please?
Uh,
Yes.
yes, our only problem, Mr. Wissam, is we just started the curriculum. So as for grade 11 and for grade 10, because their book it did not start with the basics,
Yes.
so we are giving them lessons from grade 7, just for them to get an
But
idea.
I
And
remember
then,
that from last year you started, no?
no, no, we just started this year. Last year we started with the primary only.
Ah, okay, okay, okay.
Yes.
All right. Okay, so the problem is it's difficult for the students.
Yes, they need to understand the basics first.
Of
So, like grade 11, we can't go into
the book
coding.
directly.
Yes,
Of course, of course. This is really what you are saying is 100% correct. In order to offer students this background, you have to move step backward by showing them the PowerPoint I sent you right now, the demonstration I did with you now should be given even for grade 12 as for grade 7. You understand?
yes. So the PowerPoint you sent will be
Helpful.
useful for all the grades,
Sure.
7 to 12.
Of course, of course. And if you need any question regarding any slide, please send me a WhatsApp and I can give you support and I can explain you more and more for this.
Sure, inshallah.
Okay? So so
Yes.
so so what you are saying should be done. I mean, you have to explore from the beginning since they don't have a previous background. But believe me, next year, all students that you have all students now will be prepared to for next year. It will be easy for them because the basic is done this year, and even if you did not reach the point to finish, let's say grade 11 or grade 10, never mind. The main issue is that students will really understand the concept and to start slowly, slowly by the manipulation. This is a main key for me, I believe.
Yes, exactly.
Okay? So I don't know if it's okay for tonight or if you need more examples, because I believe that in the book, if you follow step by step the book, you will lead and you will reach easily the content. The problem is, as you said, Mrs. Bashair, go for the introduction for all grades.
Yes, sure. With the PowerPoint you sent and the example you showed us.
Exactly, 100%.
Yeah.
Okay?
Yes, thank you, Mr. Wissam. And one more thing, I remember we asked you, just because we sometimes in our activities, we want to show the student how the robot input 2 is moving on the line. I'm not sure if there is, يعني we don't need to explain it to them, but at least just showing them how the robot can follow the line, the black line in the paper.
Look, Mrs. Bashair, I know that this manipulation, it's very exciting for the students, and students who will love this. But the problem is that it needs a really high level of of coding and the concept of understanding the steering of the robot left and right. You know, because look, if I let me share with you, I will open the M block program and I will share my screen. Where is my share my screen? Okay. Okay. So this is M block, you know, right? Let me change the, it was in English. You can see the M block program for the robot, Mrs. Bashair. Can you hear me?
Yes, we can see it.
Okay, so I will go to example programs, okay, and I will go for the MBOT 2 motion obstacle line follow. It's in Chinese, it's in English. Uh, this is a color line follow self introduction. I will take the key KP line follow. I think it's the blue, the black. I will open it. This is the program, okay? And the problem is يعني honestly, I can take it for me as an example that uh, how to explain students all those factors and parameters, the set left power to base power minus Kp. What is Kp? It's set Kp to 0.8. So you know, يعني, even me, I didn't went over this procedure till now. First, I'm always busy, and second, I believe that there is many activities, interesting activities to do with the students with the robot before reaching the line following. I don't know if I'm clear on this.
Yes, we understand, Mr. Wissam. Thank
يعني,
you.
yeah, the manipulation is, it's really hard because look, the formula, the -1 times base power plus Kp times quad color deviation. So how to explain? Maybe look, if you download this program on the robot, okay, it will work.
Yes, it will work properly. It will follow the black line.
Yes, but how to
Mm.
explain it till now?
Yeah, explain. Yeah,
Sorry.
explaining it, it doesn't matter. But if we have an activity like in school, and we just want to show them how the robot is moving around, So this code can work
Can
يعني
help
without
a little.
the
So
explaining.
so now you know from where to take.
Yes, I know where to take it from.
Okay. And tell me about the students with Scratch, Scratch Junior, coding language. They are excited.
They are so excited and they love it.
Great. Excellent. So if you have any question, please keep in touch with me. Always contact me. Sometimes if I'm a little bit late to reply, maybe I have some tasks to do, but I try to reply for all my WhatsApps.
Okay, thank you, Mr. Wissam.
Okay. Have a great night and thank you very much. Any other questions or it's okay?
No more question. Thank you,
Okay.
Mr. Wissam. Miss Shadia, Miss Faiza, any question you have?
Go for the PowerPoints, and if you have any question, please do contact me on WhatsApp, huh?